Everyone is talking about how AI is going to completely change healthcare, but there's this giant invisible roadblock that's holding everything back. Today, we're going to pull back the curtain on what that is, this problem of dark data, and show you how making data speak the same language is the absolute key to unlocking AI's true power.
So here's how we're going to break it all down. First up, we'll get into healthcare's huge dark data problem. Then, to make it real, we're going to follow the journey of a single patient. After that, we'll uncover the interoperable engine that connects everything. And finally, we'll see how this all comes together to fuel the future of AI. All right, so let's jump right in with the main challenge. Health systems are basically sitting on a gold mine of data, but most of it is locked up tight, almost impossible to get to.
Just think about that for a second. What if the most important thing you had, the key to innovation, to being more efficient, to providing better care for patients, was completely invisible? You can't see it, you can't touch it, and you certainly can't use it. Well, for a lot of healthcare organizations, that's the reality they're facing right now.
And there's actually a name for this invisible asset, dark data. It's all this incredibly valuable information that's trapped in a dozen different systems, all speaking different languages, all in formats that just don't play nice with each other. And because of that, it's pretty much useless for the kind of advanced analytics and AI we're all so excited about.
Okay, so this dark data thing might sound a bit abstract, so let's make it super concrete. We're going to follow the data trail for just one patient who needs an MRI. It all kicks off the moment a patient walks in. They've got a problem, the doctor figures out what's going on, and they log it in the electronic health record, the EHR. That one little entry, using a specific clinical code, that's the first domino. It's the starting point for everything else that happens. And get this, from that one clinical problem, this whole cascade of data just explodes, and every piece of it speaks a different language. The problem itself, that's coded in SNOMED. The diagnosis to justify the scan, that's ICD. The name of the procedure uses RADLEX. The images themselves are stored in DICOM. The radiologist report, that's LANC. Billing needs a CPT code, and the final insurance claim gets sent using X12. That's 7 different steps using 7 totally separate data standards. It's kind of wild.
Now, you can actually group these into a couple of buckets. You've got the clinical and imaging codes, the green and orange bits here. Think of these as telling the medical story. They capture the what, what's wrong with the patient, and the why we need to do this scan. This is the pure clinical truth of this situation.
And then you've got the other side of the coin, the administrative data, which you see here in blue. Codes like ICD-10 and CPT act like translators. They take that medical story and turn it into the language that billing departments and insurance companies can understand. This, right here, is where medicine meets money.
So you've got all these different standards, right? One for the diagnosis, one for the image, one for the bill. It's a mess. How on earth do you get them all to talk to each other? Well, you need an engine, a translator.
And the solution is actually shown perfectly right here. Smack in the middle of everything you see this bridge. That bridge represents something called the HL7 FHIR bridge, and it is the absolute key to connecting the clinical world with the billing world.
So what exactly is this bridge? Well, think of it like a universal adapter. It's a modern framework that takes the most important clinical information, those SNOMED and LOINC codes we talked about, and packages them up so they can travel smoothly over to the billing systems. This creates what you might call data liquidity, and it's what lets AI do its magic in real time, right when the doctor and patient need it.
Okay, now for the really exciting part, the payoff. Because when your data can flow freely like this, it stops being a headache, it stops being a chore, and it turns into an incredibly powerful strategic asset.
Making all this data work together isn't just some neat tech trick. It's the thing that lets AI move out of the lab and into the clinic. Let's look at 2 huge ways this completely changes the game.
It really boils down to 2 game-changing results. First, you get a massive return on your investment by automating the whole billing and claims process. And second, you give doctors and patients way better clinical decision support tools.
Let's talk money first. Before, it was chaos. You'd have constant mismatches between what the doctor said was needed and what the billing code said was done. The result? A ton of denied insurance claims. But now with this data bridge, an AI can instantly check that everything lines up perfectly, which means denial rates plummet. It's a huge win for the hospital's bottom line.
And then there's the clinical impact, which is maybe even more important. For an AI to be genuinely helpful, it can't have blind spots. It needs the full picture. And as you see here, that means pulling in data from the EHR, the lab results, and the imaging reports.
When you combine all that, you can give clinicians a much smarter, more complete view of their patient's health.
And really, this all points to a massive shift in mindset. For way too long, dealing with all of these different data standards felt like a burden, just another bureaucratic cost. But we have to start seeing this data for what it really is. It's the essential fuel for a smarter, more efficient, AI-powered healthcare system.
So I'll leave you with this one question to think about. When you look at your organization, is your data a locked-up liability holding you back, or is it the fuel that's going to power your future? Thanks for watching.